Hi guys, how are you? I hope you are fine. Today we are going to talk about EIGRP over frame relay. Uh, as you remembered, we talked about in the last video OSPF over frame relay. Now we are going to cover this subject, EIGRP over frame relay. Uh, Actually, the EIGRP over frame relay, it's quite little different between OSPF, EIGRP over frame relay, OSPF over frame relay. Why? Because EIGRP over frame relay, it's very sensitive on bandwidth. So if you have here a different bandwidth and a specific bandwidth in each line or in each access line, you have to be careful to configure the actual bandwidth for your network. This is in EIGRP. Now I'm going to cover many scenarios here. This is the first scenario I want just to explain. Then after that, the last one, we are going to take a real scenario and we will configure it with specific configurations for EIGRP over frame relay. But now just I'm going to explain how can we configure the bandwidth of EIGRP over frame relay. As you see here, before that I want just to explain just there are three ways to configure the bandwidth of EIGRP. I have pure multipoint without using any sub interfaces. The second options is to use point-to-point configurations by use sub interfaces, and the last one I can use full mesh. Full mesh I can combine with multipoint and point-to-point. So now let's speak about the pure multipoint. The pure multipoint, you have to know two things. The first one, if you have a T1 access line like this, just imagine that we have here the access line. This is access line in the hub, and there are 10, maybe there are 10 spokes, but here is in my explanation I want to use just for this from 1 to 4, just from 1 to 4. Let's suppose that we or from 1 to 3, let's suppose that we have access line with 200, we have access line with 4 virtual circuits. Yes, it could be 1 virtual circuit, 2, 3 and 4. Here is from 1 to 4, I have 4 virtual circuits. Each virtual circuit, it has 56 kilobit per second. So what does that mean? This means that the actual bandwidth of my network here, it's equal the 56 multiplied by 4, because I have 4 virtual circuits, so I have to multiply 56 by 4, so it's equal 224. So here is it for just more explanation here. I have here 4 virtual circuits multiply like this by 56, because each virtual circuit it's 56 kilobit per second, it will equal 224 kilobit per second. Kilobit per second. So this is the point-to-point, and also there are specific notes about the point-to-point about multi-point configurations. If you have, or if the total bandwidth equal or greater than the access line, so you have to configure the bandwidth to be equal the access line, because the the actual, maybe here is, look at this, we have 224 and the access line is 256. So that's good, because the actual or the virtual or the sum or the summation, sorry, the summation of virtual circuits is less than, yes, is less than the access line. So the summation of virtual circuits, it should be equal or less than the access line. It's not good to be it's greater than the access line, because there is, maybe it will be you have to face many problems in your network, like dropping packets. So be careful. If you have my example here, 4 virtual circuits, each virtual circuit is 56, so I have 224 kilobit per second. This is my actual in my frame relay, and the access line is 256, so that's good because it's less than the access line, to avoid dropping packets. This is the first note about the multipoint. The final things about the multipoint, there is just a note, or very important. You have to put the least slow virtual circuits. Let's suppose that we have here maybe 56, 56, and here is, I have, let's see, I have 256, maybe here 256, and the final one I have 56 kilobit per second. So in this cases, I should use the 56 here. I should use the 56 multiplied by 4 virtual circuits. So I don't want to multiply this to 256. Why? Because here is I have the access, I have a line or a serial with 56 kilobit per second, so I can't use 256 for this line. So in this cases, I have to put the least slow virtual circuits into the point-to-point. I can do this. So to solve this problem, so this is, it's not actually very good to configure 56 for these 3 lines, because there are 256. So what is the solution here? The solution is to use point-to-point sub-interfaces. Is strongly recommended that the bandwidth can be raised, yes, on the other. So this is, in this case, yes, we can use point-to-point sub-interfaces. Yes, we can use point-to-point sub-interfaces. So each sub-interface bandwidth should be configured to be not greater than the available bandwidth of the associated virtual circuits. And also the total bandwidth for all sub-interfaces cannot exceed the available access line bandwidth. So what does that mean? That mean is each sub-interfaces here, look at this, I have here sub-interfaces 1, 2, and 3, and 4, and also here in the hub router here I have serial interface serial 0, 1, 2, 3, and 4. Just concentrate to 4, neglected the 10 routers here. Just focus in the 4 routers here. So if I have 3 routers with 256 kilobit per second, and have just 1 router with 56, in this cases it's good, or it should, to use the point-to-point sub-interfaces for this line, just. And you have to notice this command, that each sub-interfaces here, each sub-interfaces in each router here, the bandwidth should be configured to be not greater than the available bandwidth. So the available bandwidth maybe 256 kilobit per second. That's right. So it's very, very important that don't configure the bandwidth of each sub-interface with greater than 256 kilobit per second. And also the total bandwidth for sub-interfaces here, the total bandwidth of all sub-interfaces should not exceed the available of the access line. So this is a very, very good important issue to you. And let's go back to 56 because I want to explain this scenario. So we talked about multipoint and point-to-point. The multipoint, it showed the total bandwidth of virtual circuit. As I said, the total bandwidth of virtual circuits, it should not be greater than the access line. This is a very, very, very important to you to know it. And also the point-to-point configuration with each virtual circuit on separate sub-interfaces, that each sub-interface bandwidth should not be greater than the available bandwidth of virtual circuits. And also the summation or the total bandwidth of all virtual circuits should not exceed the bandwidth of the access line. So this is very, very important to understand. Now let's suppose this is my scenarios here. I have hub routers and I have 10 routers here, spokes routers. I have hub and spokes, 1 hub and 10 spokes. I have the access line with 256 kilobit per second. This is my access line. This serial interface is 256 kilobit per second, and each serial interface, each serial interface here, it's 56 kilobit per second for 10 routers. This is the actual or the physical kilobits. This is the physical bandwidth for each serial interface here. But be careful, I have here just 256 kilobit per second. So if I used the whole 56 or the whole bandwidth for each serial interface here, this access line or this bandwidth of the access line, it will not be adequate. It will not be enough for each 10 routers here. So what is the solution here in EIGRP over frame relay? The solution is I want to divide the access line or the bandwidth of access line here for 10 routers. So let's suppose here I have 256. I want to divide it by 10. So, and it will equal 25 kilobit byte per second. So here's the solution. The solution is to divide this, and use sub-interfaces for each one. Yes, I have to divide it and I want to use sub-interfaces. Why? Just be careful, you have to use sub-interfaces here in your network if you have small access lines. Yes, small bandwidth, or it's a little bandwidth of the access line, and in each serial here for spokes it's just like 25 kilobit per second. It's just a little small of bandwidth for your network. So the best one is to use point-to-point. Yes, is to use point-to-point. Don't use multi-point, because multi-point, it's actually good for the highest. If you have 1 megabytes or 1.5 megabytes or 1545 kilobit per second, maybe for each line here, this is good one to use multi-point because you have a higher bandwidth. But here in your scenarios you have just a 25 just kilobit per second. This is too small. So this is the best one is to use sub interfaces, point-to-point sub interfaces in each router here to contact with the hub. Don't use a full mesh here. Don't use a full mesh, just point-to-point sub interfaces. So as you see here, I have 256 kilobit per second, and I have to divide it by 10 because to be adequate or to be enough for each 10 routers here. So this is my first scenario. This is the first scenario. It spoke about hub and spoke frame relay sub interfaces. So in this sub interface, you have to configure this like this, maybe in interface 0.1.2point. I have here to use this bandwidth, this command 25, and also here is I have because I have here is a small bandwidth of this line, or if this serial, this is good to use the percentage command. Why? Because I want to use just maybe I want to use 90% just of 225 kilobits here, and I want to let 10% for my or for another, maybe for another commands or for another packets. So this is command IP bandwidth dash percent, sorry, EIGRP with autonomous system, let's see 1, and the bandwidth is 90%. So I want to use just 90% of 25. How much this equal? We can see this. Here is it. 90%. Sorry, 25 multiplied by 90%. So I want to use just 22.5 kilobit per second. Yes, for my for my usually packets, and I want to serve maybe 2.5 kilobit per second for another packets. So this is, you have to put this configuration in each routers here, So this is and also don't forget, this is for spook routers. You have to put this commands in spook routers here, and also the same commands here, you have to put it here in the hub router also. So you have to put this command in hub router and spook router. Don't forget that. The same commands for hub and spooks. So this is my first scenarios about sub interface, hub and spook. Let's move to another scenario here to the right. Just yes, I have here is a new one. This is my scenarios here. It's a little challenge because here in these scenarios I want to use full mesh frame relay, and to explain this very well, I want to use snipping tool for Microsoft. Sorry, I want just to snipping tools. I want just to cut it like this. And I want just to use drawing like this. That's good. Yes, thank you, Microsoft. Now let's see this and how this happened. Let's suppose here I have router A. I have here 4 routers, router A, B, C, and D. And router A, this serial interface is 256. This in the bandwidth is 256. So my dad is coming. No problem. Now let's start again. We have 4 routers here, as I said, and I have router A. It has, look at this. So what is that? What is? Yes, I have also 265 kilobit per second for this line, and also I have for router C here, I have 256 per second here, kilobit per second. This is the bandwidth. And also look at this, I have just 56 here, just 56 kilobit per second for this line for the router D. So what is that? This means that I have A, B, and C with 256 kilobit per second, and just I have D router with 56 kilobit per second. In this scenarios, I want to use just full mesh, as I said here, full mesh with multipoint between router A, B, and C, and I have to use point-to-point between router D and C, between router C, D, and B, D, and A. So I want to use, the first one is multipoint between 3 routers here, and I want to use point-to-point between router D and other routers. So how can I do this? So let me just to show you how this scenario it will be. I want to use this like this. Look at this. I have here serial 01. I want to contact with serial 01 here of router B, and serial 01 also here of router A. I want to contact it with serial 001 here of router C, and also router C with serial 001, it will contact, yes, with router serial 00. This is multipoint. This is the multipoint configurations. So I want to use multipoint configurations for serial 01 in each router here from A, B, and C, and I want to use a point-to-point between router D here, serial maybe serial 03 and serial 02. This is point-to-point. Serial 01 with serial 02 point-to-point configurations, and also here I want to use serial 02 with point-to-point. This is, look at this, this is the best one. This is the best way to use your bandwidth. There is a simplest way. I want to talk about it. It's the easiest way is to use just 56. You have to configure 56 bandwidth for each interface here. So the another solutions without using full mesh, if you don't want to use full mesh and your network, there is no big data in your network maybe, so you are not you don't want to use multipoint, so you can use 56. You can configure the bandwidth 56 bandwidth for each serial here. For each serial you have to configure this serial with 56, 56, 56, and 56 kilobit per second, and you can go on. But if you have a big data here between router A, B, and C, and a little data here in router D, you have to use full mesh. You have to use multipoint between a big routers here, A, B, and C, and point-to-point between these routers, router D and router A, B, and C. So how can we configure this bandwidth? The first things is, look at this, I want just 56 here. I want to divide it into 3 lines because I have a 3 virtual circuit here. I want to just to divide it like this, 56 divided by 3 lines or 3 virtual circuits. It will equal 18. It will equal 18. What is this? This is not a good one. So let's go to the Genesis 3 here. It's better. So now we just look at this. For this virtual, just keep it in your mind because I want to use it in my scenario, real scenario. I have multi-points here and point-to-point between router D, C, A, and B. So now here, look at this. I have 56 here, 56 kilobit divided by 3 virtual circuits. It will equal 18 kilobit, yes, per second. So this is the first step. The first step, I want to divide the lowest. I want to take the lowest bandwidth and divide it into how many virtual circuits I have. I have 3 virtual circuits divided by 56 divided by 3. It will equal 18 kilobit per second. So in each sub interfaces here, or in each sub interfaces which connect with router C, A, and B, I want to configure the bandwidth to 18 kilobits. Now, if I configure the sub interfaces for each router here with 18 for point to point, so the 256, it will be less than this. Why? Because I have 256 minus 18 kilobit. It will become the really it will become 238 kilobit per second. So look at this. This is the point to point. This is point. This is point to point sub interfaces. This is the bandwidth of point to point sub interfaces, and this is the bandwidth of multi-point sub interfaces. So here is the bandwidth of multi-point sub interfaces, and here is the bandwidth of multi-point of point-to-point sub interfaces. Sorry. So now this is my scenario. Here is a full mesh, and now let's go now to our real scenarios to configure it with a nice configurations to know how to configure this in the real field. So now here is my our scenarios we are going to configure. As you see here, I have 4 routers, router 1, 2, 3, and 4. As you see here also, I have the bandwidth of between router for router 4 is 1545 kilobit per second. Router 2 the same bandwidth of router 4, and router 2 also the same. So I have 1, 2, 4, they are the same bandwidth with 1.5 megabyte actually, and I have here just 256 kilobit per second for router 4. For router 3, to solve this scenario, I have 2 choices here. I have a choice to use a point-to-point, just point-to-point between, for each sub-interfaces, make sub-interface, 3 sub-interface here, 3 sub-interface here, 3 sub-interface, and 3 sub-interfaces, and I configured the bandwidth of each sub-interfaces with 256. So the first solution for the first options, or the first way to solve this scenario, is create, you can see, create 3 sub interfaces for each router, and configure configure 56 bandwidth for each. 1. So this is the first choice, is to create 3 sub-interfaces for each, is to create 3 sub-interfaces for each routers, and use point-to-point sub-interfaces and configure 200. Here is to configure 200, because I used the last one 256 bandwidth. Use 256 bandwidth for each sub-interfaces. But actually this is not a good one, because here is I have 1 megabytes and half, and 1 megabytes and half, 1 megabytes and half. So why I want to use this scenarios or this way to decrease the huge or the big bandwidth to the lowest one. So another way, or the best way to configure it with is to use full mesh. I want to use multi-point and I want to use point-to-point. Here is my, so this option I don't want to use this in my configuration here, so I want to hide it. Now my configuration here, it will be multi-point and point-to-point, so I want to use full mesh. So I want to use full mesh for this router. Here is, I want to use a multi-point between router 1, 2 and 4. Why? Because they have the highest bandwidth, so I want to share this bandwidth between them with multi-point, with serial 00.1 to connect with serial 00.1 with router 2, and serial 001 of router 2 connect with serial 001 of router 4. Yes, with network address 192.168.1.0/24. So here is, I want to use this network address for 3 routers here with bandwidth with these routers. Now I want to configure point-to-point sub-interfaces also between router 3 and router 1. Router 3 and router 1, router 3 and router 2, router 3 and router 4. So let's just explain this more clear. I want to use a new snapping here. Sorry, I want to use a new one like this. Yes. So look at this. I have here is router 1, router 2, router 2, router 2, router 3 and router 4. I want to use, here is, look at this, multi-point. I want to use multi-point between router 1, here is, look at this, serial 00. I want to contact it with serial 00.1 with router 2, and serial 00.1 of router 1 contact with serial 001 of router 4, and here is serial 001 also contact, here is it like this, with serial 00. So this is multi-point sub-interfaces, yes, with this network address. Yes, and I want to use point-to-point sub-interfaces between router 3 and other routers like this. Router 3 with serial 001, look at this, I want to use a blue pen, yes, with serial 00 here, contact with, look at this, serial 00.1 of router 3, contact with router 1 by serial 00.2. So serial 001 contact with serial 00. This is a virtual circuit. This is one virtual circuit. And router 2 here, look at this, I want to use black pen, yes, with serial 00.2 contact with router 2 with serial 00.2 also. So this is the second virtual circuit. This is the second virtual circuit. And the third virtual circuit, I want to customize my color here, let's say green. Yes, serial 003. Contact with router 4 of serial 00.3, also this subinterface. So this is, here is it. So this is the third virtual circuits. So I have here 3 virtual circuits. Yes, point-to-point subinterfaces, and each subinterface here for router 3, it will has a different network address. Here 192.168.2.30, and here's 2.4, and here is 2.8 with subnet mask 30. So now, as you see here, I have sub-interfaces for each one. So now this is the second one. This is the first step. Now, how I can configure the bandwidth for each sub-interface. I want to use, the first step is to take the lowest one and divide it by how many virtual circuits I have. As you see here, I have three virtual circuits. Here is 1, 2, and 3. So I want to divide 256 kilobit per second divided by 3 virtual circuits. It will equal 85. So here is 85 kilobit per second. So I want to configure the point-to-point. Yes, the point-to-point with 85 kilobit per second for each point-to-point sub-interfaces. Yes, the bandwidth, it will be 85. So now the second step is to know how much the bandwidth of multi-point sub-interfaces. So I want just to minus 1545 minus 55, it will equal 1459. So here is kilobit per second. So here is the 1459 kilobit per second. This is the bandwidth of multi-point sub-interfaces. So I have two different bandwidth. I have to use point-to-point sub-interfaces with 85 kilobit per second and point-to-point multi-point sub-interfaces with 1459 kilobit per second. So this is the best way, yes, in my topology here or in my scenarios. So now I have also here a frame relay in the middle, frame relay switch. I want to configure a frame relay with full mesh. What does that mean? I want to make a PVC between router 1 and router 2, PVC between router 1 and router 3, PVC between router 1 and router 4. As I see here, I have 3 DLCs, 102 to 201 from router 1 to 2, and this DLC from router 1 to 3. Sorry, here is, and this DLC from router 1 to 4. Also here, router 2, I want to make a PVC, private virtual circuit, with DLC 201 to contact with router 1 with 102, and also 203 between router 2 and router 3, between router 2 and router 3, and also here between router 2 and router 4. Also router 4, I want to contact with 4 with 1, 4 with 2, 4 with 3, and also here 3 with 1, 3 with 2, and 3 with 4. Yes. So this is what I called the full mesh configurations. So let's get started with the frame relay switching. We want to configure it with full mesh, and I will show you how to configure the full mesh configuration in the frame relay switch. So now go to the frame relay. I think I have here is one. Yes. Now let's get started. Now I know this is, you are waiting for commands. So now conft, now hostname, frame relay switch. Yes. Now I want to make this router to be frame relay switch with this command. This is easy. Now I want to enter on this interface and configure my DLCs. Yes, go to the interface here 00. I want just first one encapsulation frame relay, interface type DCE with the clock rate 64,000. Now I want to use frame relay route with 102 to go to the interface serial. Here is serial 01, yes, with 201. Sorry. So this is the first one. The second one, it will be frame relay route to go from 103 to exit to the interface serial 0. Here is serial 02, yes, with serial 02 with 301. And the last one is, it will be route 104, yes, 104, exit through serial 0, here is serial 03, which contact with router 4, now with 401. So that's it, make no shutdown. Now we finished our configuration on this interfaces which contact with router 1 with these DLCs. Now go to this interface and configure with these DLCs. Frame relay switch, interface, interface here 01. I want to use encapsulation frame relay interface type with DCE. Clock rate is 64000. Now frame relay route from 201 to exit through serial 00, which contact with router 1 with 102. Frame relay route, the input DLC is 301 to go out to the serial 00 to the serial, sorry, what is that? No, this is 203, yes, to interface, because here is it, 203 go to 302, yes, through serial 002. Let's go back again to the interface serial 02 with 302. They are called it the output DLC. The output DLC, this is the DLC of router 3. Yes. The third one is frame relay route with 204 to exit through serial 0, here is, through serial 003, interface serial 03 with 402. No shutdown. Now we finished this interface. We are going to go to this interface which contact to the router 3, serial 02. Now interface serial 02, sorry, serial 02, encapsulation frame relay interface type DCE with the clock rate 64000. Now frame relay route I want to configure with this DLC, with this DLCs. Yes. Now from 301 to go to exit through 000 contact with router 1 with 103. This is the output DLC. The second PVC, it will be 302 to go to the interface serial 01. Serial 01 contact with router 2 to go out with 203 DLC. Frame relay route 304 to go serial 003 which contact with router 4 with 403. No shot. Now we finished this, and the last one it will be serial 03. Go to the serial interface serial 03 with encapsulation frame relay interface type DCE with the clock rate. Yes. Now frame relay route, I want to configure, yes, with this DLCs, just to see it. Yes, frame relay from 401 to exit through serial 00, which contact with router 104. Frame relay route 402 interface serial 001 with 204. Sorry. Yes. Frame relay route 403, the last one. We are going to be happy now. Serial 02. Yes, which contact with router 3 and 304. No shot. Show IP interface, I believe, just to make that I did all this. 000, yes, all of them, they are up. Alright, save our configurations, so I don't want it again. Now we configure frame relay switch. Now we are going to configure router 2 with sub interfaces. Just be careful, go back to this. I have serial 01 here. Yes, serial 01, serial 01, serial 01, they are multipoint. They are here multipoint. Yes. So now I have multipoint serial 01, 01, 01. Look at this. I want to configure the first one, the multipoint interfaces. Go to the router 1. Enable. Now conft, first thing, hostname router 1. Now go to the interface, to the interface serial 00. Yes, encapsulation frame relay with no shutdown. Now exit. Now look at this. I have multipoint here. Router 1 serial 00.1 with this IP address. Router 2 serial 00.1 contact with serial 001 with this IP address, and also router 4 with serial 00.1 with IP address like this. And also the bandwidth, it will be this 1459 kilobit per second. Don't forget to configure it. Now interface serial 00.1 with multipoint. Yes, the IP address, it will be this. Yes, 192.168.1.1.255.255.255.0. And now I want to just to disable inverse ARP. Yes. And no frame relay, inverse ARP. Now frame relay, I want to use, here is a static map. Be careful, I want to use a static map between router 1, 2, and 4. So I want to use frame relay map IP. Frame relay map IP. Yes, here is it. Router 1, it will contact with router 2 and router 4. And the IP destination, it will be this 1, 2, and 1, 3. So router 1, it will has two static frame relay commands. So frame relay map IP with 192.168.1.2. This is the destination IP address of router 2, sub interfaces of router 2 to go out through DLC 102. The second one, I want to use a frame relay map IP with 192.168, sorry, .1.3. This is the IP address. This is the IP address of router 4. So go through this DLC 104. Don't forget to make no shot. So here is, I finished this. Don't forget just to make the bandwidth. The bandwidth is, as I said, 1459 kilobit per second. Yes, exit now. So now go to the router 2. Yes. I want to remember, I want to make the interface loopback also. Maybe I forgot to say this because I want to use EIGRP. So interface, sorry, IP address with 1.1.1.1.255.255.255.0. So that's easy. Now go to the router 2. And in router 2 also, I want to configure multi-point sub-interfaces for this with this IP address. Yes, with the frame relay map with this destination and this destination and with this bandwidth. Yes, now go to the router 2. Just to change name, sorry. Router 2. Now I want just to create loopback. IP address 2.2.2.2 255.255.255.0. Exit. Now go to the interface here 00. I want to just to enable the frame relay protocol with this encapsulation with no shot. Now exit interface here 00.1 with multipoint. Yes, with IP address 192.168.1.2 255.255.255.0. Now I want to disable frame relay inverse ARP. Now frame relay, yes, map IP with 192. Here is it. Look at this. I will have two static map IP. Static map IP with router 1 and router 4. So the router 1, it will be 192.168.1.1 with DLC to go through 201, because the DLC which contact with from router 2 to router 1, it will be 201. Second frame relay static map IP, it will be 192.168.1. Router 413, yes, with 204. Yes, without no shot. Now show IP route. Yes, I can make a ping with router 1 192.168.1.1. Yes, that's good. Sounds good. Now go to the router 4. Enable. I want to configure this conft. First, I want to create loopback with IP address 4.4.4.4 255.255.255.0. Now exit. Now interface here 00. Sorry. Look at this. Look at this. I want to make just also 0.0.1 with multipoint to contact with router 1 and router 2. The IP address of router 4, it will be 192.168.1.3. Yes, but you know, maybe in router 2 we forget to configure the bandwidth. Interface here 00.1 with multipoint with bandwidth 1049. Yes, don't forget to configure it. Now go to the router 4 0.0.0. I want to encapsulation frame relay with no shot. Now exit interface here 00.1 with multipoint. Now with IP address 192.168.1.3 255.255.255.0. Now no frame relay inverse ARP, frame relay map, static IP with contact with router 1. This is the destination, 1.1 with DLC 401. And also here's let's see, frame relay map IP, static IP with router 2.1.2 with 402. Now exit, sorry, interface series. Don't forget the bandwidth. Yes, the bandwidth, it will be 1459. Exit. It is just, we forget the host name, router 4. Yes. Now show IP route. So that's good. I have serial 01. Now I can ping with router 1 and also to the router 2. So that's good. That sounds good. And let's now we finish the multipoint. Now we are going to the second step to configure point-to-point between router 3 and router 2, router 1 and router 4. With each sub-interfaces, it will has a different network address. This is 230, 2.4, 2.8. So because I have here 3 virtual circuits, I will have 85 kilobit per second for sub-interfaces. So now go to the router 3. Yes. Now be careful, enable conft host name router 3, interface loopback 0 with IP address. Yes. 3.3.3.3 255.255.0. Yes. Now exit, interface serial 00, encapsulation frame relay with no shot. Yes. Now exit, interface serial. Look at this, just go back to this picture. As you see here, serial 01 point-to-point, serial 02 point-to-point, serial 03 point-to-point. So now go to the router 3, interface serial 00.1 with point-to-point. Now the IP address, here is the IP address. It will be for router 3, it will be this 192.168.2.1. router 3, 192.168.2.1, 255.255.255.252, because the subnet is 30. Now no frame relay inverse ARP. Now I want to use, here is the dynamic, so frame relay interface DLC to go out, because this sub interface contact with router 1, so the DLC it will be 301. So now exit, just configure the bandwidth with 85. Yes. Now go to the second sub interface here, 00.2 with point-to-point. Here is it, 0.0.2 point-to-point. It will contact with router 2 and with IP address 192.168.2.5. Right, now IP address 192.168.2.5, 255.255.255.252. No, sorry, no frame relay inverse ARP. Frame relay. Also, I want to use the dynamic interface DLC, because this contact with router 2, it will be 302. Yes. Exit with bandwidth 85. Yes. exit. Now interface 000.3 with point to point. Here is, look at this. This 000.3 point to point, it will contact with router 4 with IP address 192.168.2.9. Go to this IP address 192.168.2.9, 255.255.255.252. No frame relay inverse ARP. Yes. Frame relay interface WLC with yes, just wait a second, with 304. Yes, and the bandwidth I want it 85. So just we finished the router 3. We don't have anything else. Show IP route. Yes, 3123. That's good with the loopback interface. So we finished here. So now go to the router 1 and create interface 000 dot. Here is it. Look at this. It will contact with, like in our picture here, 000 contact with 0.2. So router 1, it will be 0.2 with point to point. Yes. And point to point, the IP address of router 1 here is 000. It will be 192.168.2.2. So IP address 192.168.2.2, 255.255.255.252. No, sorry, no frame relay inverse ARP. Frame relay here is interface WLC through 103. Yes, exit. Don't forget the bandwidth here for point to point 85. Exit. Now I'm going to go to the router. We finished router 1. I should ping to the router 3 like this. Ping 192.168.1. Sorry, .2.1. Yes, that's good. So I can ping to the router 3 through this sub interface. Now go to the router 2. Config interface 000.2 with point to point, because here is contact 000.2 with 000.2 with router 3. The IP address, it will be this router 2 192.168.6.2.6. sorry. So router 2 IP address 2.168.2.6, 255.255.255.252. No frame relay inverse ARP. Forget the bandwidth with 85. Now frame relay interface WLC go through 203, because this is the WLC contact with router 3. Now show IP route. Should be here. Yes, 002. I can ping 192.168.2.5. Yes, that sounds good. Now the last configuration for frame relay in router 4. Conf T interface 000 dot what? Let me just. Here is dot 3, because dot 3 contact with dot 3 router 3, and the IP address of router 4 for this sub interface is 192.168.2.10. So dot 3 with point to point. IP address 192.168.2.10. Yes. Yes, now 255, 255, 255, 252. Now, no frame relay inverse ARP. Frame relay, sorry, don't forget the bandwidth here. 85. Frame relay interface DLC go out through 403. So now I think we finished. Show IP route. Now we can ping to 192.168.1.9. So why? Sorry, 2.9. Yes, that's good. Now we finished this. As you see here, just to go to the router 1 to configure, to verify the show frame relay map. Look at this. I have here two static. Yes, the two static frame relay map. Yes, with non-broadcast. Be careful. We have here, we don't have broadcast here because we did this configuration. Just I want to show you here what I did here. Yes, look at this. I use this command without broadcast, so I disabled the multicast. So I want to use a unicast like the OSPF. Here is the EIGRP, is the same thing. Yes. So to configure it, you have to use this. So now we are going to configure the EIGRP conf t. Now router EIGRP .1, the autonomous system 1. Now I want to use network 0.0.0.0 with welcome 255.255.255.255. Just I want to configure the whole thing. No auto summary. Yes. Now go to the router 2. Here is it, router 2. Conf t router. Sorry, EIGRP 1 network 0.0.0.0 255.255.255.255. No auto summary. Yes. Now to the router 3. Conf t router EIGRP 1 network 0.0.0.0 255.255.255.255. And no, look at this. Here is we have adjacency here between router 3 and the router 2 with the router 1. So look at this. Show IP route EIGRP. Yes, look at this. Router 3 contact with router 1 and router 2. Why? Because here's, look at this, show frame relay map. Because here is, I have broadcast. So because EIGRP, it used a multicast, not a broadcast, multicast access. This is the frame relay. So it will make the adjacency without use the neighbor command. So this is a good one to notice this, like OSPF in somehow. So now go to the router 4 to complete our configurations. Now go to the router 4 here. Now router EIGRP 1. Now network 0.0.0.0 255.255.255.255. Yes, he make adjacencies with router 3 with no auto summary. Yes, so that's good. Now look at this, show IP route. Router 4, look at this, he says 1 and 2. Look at this, router 4 he sees the router 2, look at this, the loopback of router 2 through serial 0.3. So look at this, here is, it will be more clear. Router 4, he says he sees the router 2 loopback with serial 0.0.3. So I don't want this. I don't want router 4 to go to this way. Yes, to go through this way to reach router 2. I want router 4 to use this way, just from serial 0.0.1 to serial 0.0.1. So I want to configure, to complete my configuration EIGRP with neighboring EIGRP 1. I want to use, here is router 1. It will has two neighborship with 192.168.1.2 with router 2. It will goes out through serial 00.1. Yes. Here is the serial 00.1. This command, it's not exist in OSPF, just here is in EIGRP now. And also I have neighborship with 192.168.1 with 4 with .3, yes, because here's .3, router 4 with 0.0.1, yes. So I show IP EIGRP neighbors. Yes, here's he make this one, but he make it through serial 0.2, so I don't want this. Look at this, everything will change when I complete my configurations here. Router 2, I'm in the EIGRP, yes, neighboring with 192.168.1. Neighboring ship with router 1, yes, 0.0.1, and neighborship here 192.168.1. Yes, look at this, he make a new neighborship, yes, new adjacencies with router 1, so that's good. .1.3, because router 1 with router 4 with 0.0.3. So why is this not happen? 0.0.1, sorry, not 3. So now go to the router 4, complete the adjacencies here, conf-t. Look at this, now this way will change from 0.0.3 to 0.0.1. Now you will see it. Router EIGRP 1 with network, sorry, with neighbor 192.168, sorry, .1.1. This is the IP address of router 1, goes out through 0.0.1. This is subinterface 192.168.1.2 0.0.1 also. Now it should take a little bit of time. Yes, he makes adjacencies, that's good. So now show IP route EIGRP, let me see. Yes, look at this, he router 4 contact with this, with router 1 and router 2 through this serial subinterface, so that's very good. Yes, show IP EIGRP neighboring, just to verify this. Look at this, he make a neighborship with IP address 192.168.1.1 and .1.2, .2.9 with, yes, .1.1.1.2 with this subinterface, because I make this multipoint. Yes, because I made this the multipoint, and this is the point-to-point with router 3. So that's good. Yes. So now that's everything. Yes, about the EIGRP. There is a little bit different about OSPF, and I don't face here the IP split horizons, because I used a full mesh between multipoint. If I don't use the multipoint or a full mesh between multipoint, so I have to use IP to disable the IP split horizon. This is easy. So as you see here in my topology, I have 3 serials with 1 megabyte and half bandwidth, and 1 serial with 256 kilobit per second. I divided this into 3 virtual circuits, because it has 3 virtual circuits. It will be 85 kilobit per second, and I minused the 1545 minus 85, it equals 1459 kilobit per second for each multipoint here. So point to point, the bandwidth of point to point, it's 85, and the bandwidth of multipoint is 1459 kilobit per second. I made a multi-point between router 2, 1, 2, and 4 because they have the highest bandwidth, and I make point-to-point sub-interfaces between router 3 and each router here because it's a slow bandwidth, or a little bandwidth 85. So that's everything. I hope this video to be beneficial for everyone, and follow me in the next video, and have a nice day. So bye bye.